This is the third of 3 lessons on the quadratic equation, most specifically on how to solve quadratic equations. Recall that we're talking about the quadratic equation in standard form, where we have ax squared plus bx plus c equals 0, where a, b, and c are constants, and a does not equal 0. We've talked about that there's 3 main methods of solving. The first, which was our lesson 1 of 3, which was on factoring. Our second, which was on completing the square, and now this third lesson, which will be on the quadratic formula. So that's the focus of this lesson. So the lesson on the quadratic formula, we're just going to see how it's developed, and then we will use it in class, do many examples in class. So this is just how it's developed. Take notes on this because it is important where we get the quadratic formula. And the quadratic formula builds on completing the square, so make sure you've seen the video on completing the square so you truly understand how we solve a quadratic equation by completing the square. Recall that the format that we ended up with for completing the square was this idea that when we make sure that our a is a 1, so we've divided any quadratic equation we have to ensure that our a is actually a 1. And then we will have this bx, and what we would do to complete the square is we would add half of b squared. And when we do that, when we add this half of b quantity squared, this trinomial now can be factored into the binomial squared, and that is the action of completing the square. So we've got to ensure that we've got this coefficient of 1. That is part of the big process here that I've seen a lot of students work where they forget to make this coefficient 1, and then the completing the square goes horribly wrong. So make sure you start off with that. And what we're doing there again, when we see b over 2, don't forget that just means half of b that we're putting in there. So we're starting off with our quadratic equation in standard form where it equals 0, and we know that our a is not 0. So this is what it starts off with. And the a has to be a 1. So right now, since we're looking at this as the general case where it could be anything, we need to make sure that that a is a 1. And the way to do that would be to divide everything by a. As long as we divide every term by a, we know that that first coefficient will be a 1. And while I'm still this is what we're calling our b, it's now b divided by a. This is, when we're talking about completing the square, this number that this represents is now our new b. And so the next step is to isolate these first 2 terms. We needed to isolate these 2 terms, so we subtracted the c over a, so we put it over here. And I left a gap because it's going to look a little bit better if I have the gap here of what we're going to add to both the left side and the right side to complete this square. So to complete the square, we add half of the b over a quantity squared, and we add that to both sides. Well, we need to take a little bit of a moment here to look at that what we have right here, what this is, b over a divided by 2. Remember, it's the same thing as saying, well, 1/2 of b over a. And what that is b divided by 2a. So this is what I want to write instead of it in this method here. So I'm going to rewrite that portion there, and that will become what is inside of my binomial squared. Now, on the right-hand side, we actually want to square this because we're going to try to combine these 2 fractions that we have. So let's look at this green portion here, the b over a divided by 2. Well, we already know that that's going to be b over 2a. So now we're going to square it, and when we square it, we're going to square the b, and then we're also going to square the 2, and we're going to square the a. So we end up with b squared divided by 4a squared. So now we have 2 fractions, but they don't have a common denominator, so I'm going to multiply the c over a times 4a over 4a. That way my denominator here will be the same as the other fraction. I'll have common denominators. But I still have 2 fractions, although they have a common denominator, so I'm going to write it as 1 fraction over the common denominator. Well, at this point, I have a perfect square. This is a group that is being squared, equals this 1 fraction. So my next step is to take the square root of both sides, remembering the plus and minus. And remember that when you're taking the square root of a fraction, it's no different than taking the square root of the numerator and taking the square root of the denominator. And this denominator is a perfect square. Wonderful. So we're going to rationalize that denominator by doing the square root of it. And we end up by simplification. And remember over here we had a binomial squared, and the squared root of anything squared is just to the first degree here. And our last step is we want to isolate the x, so we need to eliminate this term from the left-hand side. So we're going to subtract it. And then we're going to, now that we've subtracted it from the left-hand side, we need to combine all of this. You'll notice that both this fraction and this fraction have the same denominator. So I can write this up in the numerator. I can put the negative b right up there. And what we end up with is the wonderful quadratic formula that says the solution to the quadratic equation is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So remember that if you have a quadratic equation in standard form and the a does not equal 0, then the solution to any quadratic equation in this form will be the quadratic formula where x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. This allows us to solve with what I call plug and play. Identify your a, identify your b, identify your c, plug it in to the formula, and then evaluate all of that, and you will have the solution to the quadratic equation.